Welcome to this YouTube channel. In this video, I will discuss about the DFT question which is asked in GATE 2016 to 2021. Now let's start the first question. In previous video, I have discussed the GATE 2014 to 2015 and which is cover 1 to my 7 number question, and here I will discuss in this video. Okay, now let's start the first question. Given the discrete Fourier transform DFT of the 4-point sequence xn is given 3, 2, 3, 4. Okay, and xk for xn DFT is given 12, 2j, 0, -2. If x1k is the DFT of 12-point sequence where sequence is 3, 0, 0, 2, 0, 0, 3, 0, 0, 4, 0, 0, the value of x1 8 upon x1 11 is, means we have to find out the DFT of x1k, and at there we have to find out the magnitude of 8 position and 11 position of division. Okay, so first think about the x1n. X1n is nothing but x1 xn, where there only zero padding, two element of zero padding between the two elements. Okay, two element of zero padding between the two elements, and when you take the summation, then it will be the comes the same. Okay, so check it first. See or think about the xk. What is the xk? Xk is, we know that xk is summation of n is equal to 0 to capital N minus 1 and x n e to minus j 2 pi n k upon n. Okay, so when you take the x1k, when you take the x1k, so it will be the same, will be the x1k, so it will be the same 3 times. It will be repeat your xk, because the summation will be always same. Summation will be always same, means summation of xn is always same. And here is, it will be, you will take the 12 because of 12-point DFT, so and 12, and it will be repeat after 4.4 4 by 4 because here is the 4. So you can check it x1k, and directly we can say that 12 2j 0 -2 12, once again 2j 0 -2, it again 12 2j 0 -2, it will become. Okay, and from here you can find out the x1 8 and x1 8 upon x1 11 mod. So 0 1 2 3 4 5, 0 1 2 3 4 5 6 7 8, 8 position, 8 position is 12 upon 8 9 10 11, 11 position is minus 2. Okay, wait, something mistake here. Okay, here is the given to -2 and take it mod, and what will happen here? 6, then answer will be 6. Okay, so now comes to next question. Next question is, a continuous time speech signal xat is sampled at a rate of 8 kHz, and the samples are subsequently grouped in blocks, each of size capital N. The DFT of each block is to be computed in real time using radix to decimation in frequency FFT algorithm. If the processor perform all operations sequentially and take its 20 microsecond for computing each complex multiplication including multiplication by 1 or minus 1 and the finite required for addition subtraction is negligible, then maximum value of n is, we have to find out the maximum value of n. Solution gate 2016 fs, what is the sampling frequency is given 8 kilohertz. Okay, so fs is equal to 8000 sample per second. Okay, and ts will be 1 by fs and 1 upon 8000 second. So time of each multiplication is given, time of each multiplication is given 20 microsecond, tm is given 20 microsecond. So tm is equal to 20 into 10 to the power minus 6 second. Okay, suppose block of size is n, which is given, then the time taken by generation of each block will be time taken to generate each block is equal to n into ts, n into 1 upon 8000. Number of multiplication that can be performed by processor is taken by each block is equal to processor time taken n into ts upon tm. So 2 point DFT by radix 2, DFT by radix 2 FFT algorithm, will be n by 2 log 2 to power n. Okay, so when comparison it, number of multiplication required by FFT, less than, should be less than number of multiplication that can be performed by the processor in time taken each block. So n by 2 log 2 to power n less than n into ts upon tm. Okay, so after calculation log 2 to power n should be less than, and here we will get 2 upon 2 into and cancel out, so 2 will be 2 into ts is equal to 1 by 8000 upon 120, tm is 106 is equal to 12.5. okay, so n should be less than 2 upon 12.5, so n should be less than 2 upon 12 approximately and equal to 96. This will be the answer. Now comes to next question. Let Hn be the impulse response of a discrete time linear time invariant LTI filter. The impulse response is given. At 0 position 1 by 3, at 1 position 1 by 3, 2 position 1 by 3, and Hn is equal to 0 for n less than 0 and n greater than 0. 2. Let H omega be the discrete Fourier transform DTFT of Hn, where omega is the normalized angular frequency in radian. Given that H omega 0 and omega is 0 to pi, the value of omega is 0 is equal to, we have to find out the omega 0. Okay, Hn is given 1 by 3 del n plus 1 by 3 del n minus 1 plus 1 by 3 del n minus 2. Okay, so as we can take the Z transform, what will happen? 1 by 3 plus 1 by 3 z inverse plus 1 by 3 z minus 2. Okay, and take the Fourier as e to j omega 1 by 3 plus 1 by 3 e to minus j omega plus 1 by 3 e to minus 2 j omega. And you can simplify it, and when you simplify it, what will happen? 1 by 3, take the common, and take the common 1 by g omega e to power g minus g omega e to minus g omega. What will happen? Here it becomes e to power j omega plus 1 plus e to power minus j omega, and e to power j omega minus e to j omega cos omega Euler formula, cos omega plus j sin omega, and here is the cos omega minus j sin omega. Okay, so e to minus j omega by 3 is equal to 1 plus 2 cos omega. Okay, and here is given as e to j omega will be 0 at omega 0. Okay, so let us consider it is 0 at omega 0, then it becomes e to j omega 0 upon 3 1 plus 2 cos omega naught is equal to 0. So 1 plus 2 cos omega naught is equal to 0. So cos omega naught is equal to minus 1 by 2, and omega naught is equal to 2 pi by 3. So 2.10 radians. Okay. Now comes to next question. An LTI system with unit sample response Hn is given. Is we have to find out which type of a filter is. Okay, system is given, and we have to find out the check the system. Let us consider Hn given. Hn is equal to 5 del n minus 7 del n minus 1 plus 7 del n minus 3 minus 5 del n minus 4. It is given. Okay, and take the Fourier directly as e to power j omega will be 5 minus 7 e to power minus j omega plus 7 e to power minus 3 j omega minus 5 e to power minus 4 j omega. Okay, and now put omega is equal to 0. Then what will happen? As e j 0 is equal to 5 minus 7 plus 7 minus 5, it will be 0. At omega is equal to pi will be as e to power j pi. Cos pi will be 0. Cos pi will be minus 1, and from Euler formula, and j sin pi will be the 0. Okay, so it will be the 5 minus 7 minus 1 plus 7 minus 1 and minus 5 1, because here is the 4 pi. So what will happen? It will be the also 0. System is attenuating low and high frequency, whereas passing the mid frequency. Okay, so it is a band pass filter. Okay, because at low frequency is also 0 and at high frequency is also 0, it means anywhere it will pass only band pass filter. Okay, now next question. Let xk is equal to k plus 1 0 to 7 be the 8-point DFT of the sequence xn, where xk is given. Okay, we have to solve out, and the value of n is equal to 0 to 3 x to n, and xk is given for 7. Okay, 8 0 will be 1, 8 1 will be 2, 8 2 will be 3, like this way. 4 5 6 7 8 8, it will be DFT of sequence xn, where xk, the formula DFT is given. Okay, we have to find out the DFT for 0 to 3 and for signal x to n. Okay, so we know that xk will be summation of n is equal to 0 to 7 xn e to the minus j 2 pi kn by 8. Okay, so n is equal to 0 to 7 x n e to the minus j pi by 4 kn. Okay, so now n is equal to 0 to 3 x to n. We have to find out the values. Summation n is equal to 0 2 4 6. It will become, when you put the 0, it will be the 0. When you put the 1, it will be 2 and 2 3, and we can write the xn. Means we have to find out that position only, and we can simplify it half summation n is equal to 0 to 7 xn plus minus 1 to power n xn. Okay, because at 0 it will be the 0, and 2 times of xn x0, and so then after division of 2 it will be x0. At 1 it becomes the vanish 0, like this way. So summation of n is equal to 0 to 7 x n will be x0, and it will be 1. Okay, it will be, total summation will be xk 0 and 1 forever. Now summation n is equal to 0 to 7 for minus 1 to power n xn will be summation n is equal to 0 to 7 xn and e to the minus j pi by 4 and 4n. So it will be x to 4, and here is the value x 4 0 1 2 3 4. 4 value is given 5, so it will be the 5. So summation n is equal to 0 3 x to 1 will be half 1 plus 5, and the answer will be 3. Now comes to next question. It is desired to find the 3-type causal filter which gives the causal filter which gives the 0 signals as an output to an input. The form xn is equal to c1 exponential minus j pi n by 2, c2 exponential j pi n by 2, where c1 and c2 are arbitrary real numbers. The desired 3-type filter is given by h0 is 1, h1 is a, h2 is b, and hn is equal to 0 for n less than 0 and n greater by 2. What are the value of the filter type A and B if output yn is equal to 0 for all n where xn is given above? We have to find out the A and B value. See, xn is given xn is given c1 e to the power minus j pi by 2 n plus c2 e to the power j pi by 2 n. Okay, and omega 0 is equal to pi by 2 radian per second, and H is omega is equal to Hg omega is equal to 1 plus A e minus j omega plus B e minus j omega. Okay, so from here given, okay, so B e minus j omega h2. So sorry, e to power minus 2j omega, because 2 is given, h1 h2 2j omega is given. To get yn 0, to get yn is equal to 0, so h e to power j omega, sorry, omega naught is equal to h e to power j omega, omega is equal to pi by 2, it becomes the 0. So 1 plus a e to power minus j pi by 2 plus b e to power minus j pi, because here is the 2, so equal to 0. So 1 minus ja plus minus b is equal to 0, and check it which option will be the satisfy the answer. So a will be the 0 and b will be 1, then you will get the right answer. So option D will be the right answer. Now question number 14, this one is asking grade 2019. Okay, consider a 6-point decimation in time fast Fourier transform FFT algorithm, for which FFT is nothing but it is a method for solve the DFT, okay, and simple method, for which signal flow graph corresponding to x1 is shown in figure. W6 is given, exponential minus j pi 2 pi by 6 in the figure. What should be the value of the coefficient of a1, a2, a3 in terms of W6 so x1 is obtained correctly? Okay, all the things is given, and we have to find out. So xk, we know that xk is summation of n is equal to 0 to n minus 1 xn e to the minus j 2 pi by capital N k n. Okay, so here is we have to find out x1. What will be the x1? Summation of n is equal to 0. Here is the 6 point, so it will go up to 5. Okay, and xn and w6 n, sorry, w6 n. So here will be x0 plus x1 w6 n is equal to 1, and x2 w6 2 plus x3 w6 3 plus x4 w6 4 plus x5 w6 5 plus that. From the given above flow graph, xk is equal to x0 minus x3 a1. Let us see x in zero position, at zero position here from 0 and subtraction of x3 from here. X3 is given, and some x3, okay, x0 minus x3 and a1 will be come here from here. X0 minus x3, okay, or multiplication of a1. So a1 plus next will be x1 minus x4 a2 plus x2 minus x5 and a3 by comparing an above equation. Okay, above equation 2, then you will get comparison. A1 is equal to 1, a2 is equal to w6 and a3 is equal to w6 by w6 2. Okay, and you can compare it and you will get the same thing. Put it comment from here, and x1 x4 and x2 x5, and after that compare it. Then we will get a1 equal to 1, a2 equal to w6, and a3 equal to w6 2. Okay, so answer will be D. Now comes to next question. If finite duration discrete time signals a finite duration discrete time signals xn is obtained by sampling a continuous time signals xt is equal to cos 200 pi t at sampling instant t is equal to n by 400 and 017. The 8-point discrete Fourier transform DFT is defined as is given. Which of the following statement is true? We have to find out which of the following statement will be true. A finite duration discrete time signals and a sample is given. Okay, and we have to find out. Wait. Wait. Option is only x3 x3 are non-zero, and only x4 is non-zero. Yeah. Solution. Sampling is given. Sample t is equal to n by 400. Okay, so it will becomes the action from the t. Okay, so action t will be cos 200 pi n upon 80 instant. We have to put it. Okay, 400. So t is equal to 1. So action will be after 2 cos pi n by 2, and action becomes put the 0, it will cos 0 will be 1, put 1 pi by 2 will be 0, 2 3 pi by 2 minus 1, and 4 2 pi 0, and it will be repeat 1 0 minus 1 and 0. And here is the given uh, 8 point DFT. So we have to find out the x1 is equal to 8 up to 8.0 to 7. Okay, and xk will be n is equal to 0 to 7, and xn w and k. Okay, so here is the n is the 7, and when we will calculate x4, so n is equal to 0 to 7 xn, and heat from minus j 2 pi upon 8 k, and k is 4 into n upon 2, so it will be the here is the 2 to cancel, and minus j pi n, so j pi n it will becomes summation of n is equal to 0 to 7 xn and minus 1 to power n, and x4 will be 1 minus 1 plus 1 minus 1 is equal to 0, and x2 will be summation of n is equal to 0 to 7, and x2 is equal to xn, and heat from minus j 2 pi by 8 into 2 into n. Here is the 4 and 2, and after that we will get summation 1 plus 1 plus 1 is equal to 4, and we know that as xk is complex case conjugate of x and minus k. Okay, and let us consider x, we know x2, then we will get x2 is equal to complex conjugate of at minus 2 and complex conjugate of x6, so only x2 and xc will be are non-zero, otherwise all will be the 0. Okay, so x2 and x6 will be x3 are non-zero, and other will be option D will be the right answer. Now comes to next question. Consider the sequence consider a signal xn is equal to 2 to power n minus 1 un minus n plus 2, and yn is equal to 2 to power minus n plus 2 un plus 1, where un is the unit step sequence. Let x e to power j omega and y e to power j omega be the discrete time Fourier transform xn yn respectively. The value of integral, we have to find out the value of integral, which is asking GATE 2021. Okay, so xn is equal to 2 to power n minus 1 u minus n plus 2. Okay, and yn is equal to 2 to power minus n plus 2 and u n plus 1. So y minus n is equal to 2 to power n plus n plus 2 u minus n plus 1. So v is equal to given 1 by 2 pi 0 to 2 pi x e to power j omega and y e to power minus j omega and d omega. So we have to find out the value of v. Let's check it. Then what will happen? Z n will be xn convolution of y minus n, because it is omega discrete time plot transform x and y respectively under the signal action. So y1 will be like with them zn is z e to power omega. So zn is equal to 1 by 2 pi minus pi through pi inverse z e to power j omega and e to power j omega and t omega. Okay, so z0 will be 1 by 2 pi minus pi 2 pi z e to power j omega d omega. Comparing equation 1 and 2. Equation 1, what is the equation 1? This one, and equation 2, this one. After comparison, we will get z is equal to z0 is equal to v, and z e to power j omega is equal to x e to power j omega and y e to power j omega. Okay, and applying the DFT, zn is equal to xn convolution y minus n. Okay, and xn convolution pn, we can say that pn is nothing but y minus n, and here is the 2n plus 2 and u minus n plus 1. So after simplification, z is equal to 0, k is equal to minus infinity 2 k minus 1 u minus k plus 2 n minus k plus 2 u minus n plus k minus 1. Okay, so after simplification you will get summation k is equal to minus infinity to 2, up to 2, and we will get 2n plus 1 u k minus n plus 1. Okay, and z0 is equal to v, and we will get k is equal to minus infinity to infinity 2 to power 1 u k plus 1. Okay, k plus 1, and after summation, and k will be defined minus 1 to 2, minus 1 to 2, and 2 outside u k plus 1, and it will be the 2 and minus 1 at minus 1 1 plus 0 1 plus 1 1 plus 1, and it will be the 8 answer. Okay, now comes to next question. Consider two 16 point sequence xn and hn. Let the linear convolution of xn and hn be denoted by yn, while zn denote the 16-point inverse discrete Fourier transform IDFT. The produce the 16-point DFTS xn and hn. The value of k for which zk is equal to yk is r. Solution. If two endpoint signals x and hn are convolving each other, the linearity and circularity, then yk will be zk 8 k is equal to n minus 1. Okay, and yn for linear convolution of xn and hn, and zn is circular convolution of xn and hn. So, and ln is equal to 16. So yk is equal to zk, 8k is equal to n minus 1 is equal to 15. So k will be 0 to 15, and no, 0 to 15, not k is equal to 15. So option B will be the sorry, option C will be right answer. Okay, option C will be the right answer.